Good afternoon, all. Welcome to the class. And today we are going to continue with some more discussions on the linked list. In the last class, we have talked of doubly linked list. And for doubly linked list, I have suggested all of you to try for insertion and a deletion after, of course. And then also I said before also you can try, which is the additional facility in case of the doubly linked list. So I'm sure you have done that and should not face much of a problem. But for those still, for the convenience and help of all of you, those who need some assistance in writing the code, I'm just demonstrating you the implementations for all this. So first of all, just going to the implementation for the corresponding main. Obviously, we will have the various operations. Create a new linked list, traverse forward and traverse backward. Insert after a given val, delete after a given val, insert before, delete before, call the correspondingly, and then give the choices over. The corresponding function, okay, test cases I'll show later, but let's see. First of all, traverse forward. We have already discussed forward traversal, simple, or is the same as it is. Backward traversal. First, I will reach to the last node. So by reaching to the last node while going up to temp arrow next, so I'll say while temp arrow next not equal to null. This is one and the same thing, whether you write like this or this. So null is in capital, and then you will write a temp to be traversed, and then back traversal can be done. If the list was empty, of course, we will be continue exiting, and that way we will be returning from the function. So then from return backward and then keep on printing, back pointer being used. Simple. Node create, nothing changed, all of the same code as it is. Insert after val. Of course, now, assuming that value is always there, the same condition in the singly linked list after val, whatever we have done, exactly same still. After that, malloc. One point to be remembered, whenever you want to use malloc, in some compilers, you might get a warning, etc. So it's always needed that whenever you want to use malloc, you have to include stdlib.h. Ideally, I should have told this at the first lecture itself during the pointers discussion, but it skipped my mind, so I forgot. So just remember that I have to tell you today this also. So always do stdlib.h to be included. So insert after, now created the nodes and then linking to be done. So whatever node, the code yesterday we have discussed, the same exactly code written with a condition that if it is the last, if it is being inserted after the last node, then your next node after current won't exist. And in that case, back pointer will not be possible. Rest all code is same. So whenever you have a next pointer, you have corresponding back pointer. Whenever you have a next pointer, you have corresponding back pointer. So this pair continues as we discussed. Delete after val, again same thing. This we have already done earlier also. This code also has been more or less same which we have done earlier. But whenever we have a next pointer being changed, you have to also think of back pointer. And that will also be a special condition. If the last node is being deleted, after that, there is no more node available. So if that node doesn't exist, then back won't be possible. Otherwise, you can do this. Insert before. Now, insert before will have return type must, because you have to have node start being changed, and insert before first val will mean the start pointer will change and we have to return that. Code remaining similar. Of course, I will be going up to the particular val, but once I have reached to the val, the linking can be now the reverse way. I have reached to the val, so current is my pointer, which is the next pointer. So my temp will be new created. Then I will say now temp's next node will be current, and current's back node, which I say temp2, will be first. So my sequence will become temp2, followed by temp node, followed by current node. Accordingly, linking node done. Current's back is a temp, temp's next is a current. And temp's back is guaranteedly temp2. Temp2 will be the first node. Temp2 was before current. Now it will be before that. But if temp2 was null, that means current was first node, temp2 was null. In that case, I cannot have the temp2 arrow next. So if temp2 is not the null value, then this link will do. Again in pairs, this is back and next update is here back and next updated. But if temp2 was null, that means head pointer is changing. So I will have head changed and changed head will be returned. If the head has not changed, unchanged head will be returned. Similarly, for the delete before, I will take my current pointer to reach to the val value based. And now my temp pointer is which is to be returned, to be deleted before node. So temp is to be deleted. It's a valid node, guaranteed, we have assumed. But before that, a node might or might not exist. So I say, first of all, current arrow back to be updated, and current arrow back will mean the corresponding next also to be updated. So if there is a node before the deleted node also, then this link will work. Otherwise, that means this was the first node being deleted. That means head being updated. And then accordingly that. So there is only one pointer change. So that pointer in pair, back and next pointer being updated. I'm writing before link, before deletion. So I'm starting with the back pointer being updated and then followed by trying for the next also to be done. So fairly simple code. I'm sure all of you must have done that without much of a difficulty. So now let's resume to the today's discussion, and what we have now to discuss is some more extensive programming with the pointers and linked list. So till now, what we have done, you have understood well. I'm sure now you are feeling much more comfortable, and I'm sure you are enjoying discussions with the pointers and linked list. And you will find it really interesting, and you will have a passion of programming, and you will be deeply involved into this if you start enjoying it. So in general, I will say now, first homework I will try you, or I'll tell you to try is now insert and delete at any position. Insert, delete in a doubly linked list at a position, POS. For simplicity, you can assume POS to be always valid and then try to implement this, but it could mean position as 1 also. So position equal to 1 means insertion at the start, the starting position. So deletion at the start or insertion at the start will mean the pointer changing, start pointer changing, that also you have to handle, and other cases also you have to handle. Effectively, it is no way different than your insert or delete after what you have done or before you have done. So after a value you have done and before a value also you have done. So nothing special. Special cases are like if it is first node, take there as a separate case and rest everything. Exactly same you have already done for singly linked list. So effectively, wherever in the singly linked list you have to done already the work, the pointers updation or link updation, you must ensure in pairs. So that pair you have to just check every time, and in pair only you have to do. Whenever you are touching the next pointer, also confirm to check the corresponding or some other node's back point. So that should be always done in pair and no mistake will happen. Secondly, whenever you are implementing that, always test your results for the traverse forward as well as for the traverse backward. That must be done after every operation and both must be tested. So I'll show you the test cases for insert, delete after, and similarly, you can also try for the insert or before or insert before or insert after position at a position also. So this is a create forward traversal should give this, then try insert after 30, then delete after 30, insert after 40, delete after 40. Then similarly, you can try for insert before 40, before 40, insert before 15, and delete before 15. So this also includes the first node being inserted or deleted, and this also includes the last node after last node being inserted or last node being deleted. So those cases are here. You must practice this, and then this will give you excellent confidence in this direction. Let's resume further. Now what we say is extend further. So some more practice on linked list. And effectively now, some more practice will mean use of this linked list. Using linked list for application. different application. Till now, we have done effectively is something like we have an array. In array, we have insertion and deletion, etc. Traversal creation. Of course, that is storage. But now let's use linked list for various applications or operations. For example, I may be interested to do a linked list usage for stack, etc., etc. But now when I talk of that, I will need some additional knowledge. What else? Till now, whatever we have discussed is we have always said node star create. So updated pointer start or whatever was being returned. Yes, it works. Just recall when we have done insert before. In case of insert before or insert at some position, in these cases, the call was something like, I will be forced to write start equal to insert before position or before val. And then I will have start passed here also along with whatever. Just see, we have to pass start twice. We have to write start twice. Reason we know, here the initial linked list is being sent and here the updated start is being returned. But my question is obvious. When we are already supplying the start, can't we do something that we need not write this and this start gets updated? Yes, you are right. I'm saying this parameter to get updated. Of course, you know how to update a parameter. You remember now call by reference. So I want that now my call or my function of insert before should be like void insert before val. And if I want this function to be void, whatever I write here in the main, etc., whenever I will call, the call will be not something equal to, but I will say insert before val function. And whatever parameters I supply here, that should be able to change the updated or change and update start. Updated start must be visible here if changed. If not changed, of course, initially it was one. Okay. So it must be visible now. That will mean I need the pointers to be sent via call by reference. So earlier I was sending start from here along with whatever else I needed. That will mean the call will become with call by reference. So I will be needing an ampersand to be passed. As soon as I say I need ampersand to be passed, the parameter passing method here will require double star and whatever other parameters were. But the most important point here to see is that I will need here double star. The purpose of all this is there, yes, via this also in the book also somewhere you will see double star used. So you can see node star start is the original pointer. This star tells that it's a pointer. But the second start is for call by reference. And if I have to pass call by reference a pointer itself, so this requires extra star, that will mean 2 stars. So one change here, call will be like this. Another important point, wherever you have used start in this code here earlier, now you have to use star star. So you should use star start throughout in this code. In this function, wherever you have used start, you should use now star start. Replace that everywhere, put brackets so that will ensure the corresponding precedence or any kind of a priority issues with the other operators, and it will ensure everything. Nothing else will change. Similarly, when you said create, so one way of doing a create was node star create, and without parameter it worked. Second method, It could be void create, and I can send void create node star star start. And throughout code, now you want to declare node star start. This declaration won't be needed. You remember that because this is already as a parameter declared. So this is one change. Secondly, throughout the program, wherever you have used the word start, you will use a star start at that place. And thirdly, from the main, when the call will come, now you will call it as create and ampersand start, not start equal to create. So one change, second change, third change throughout, and a fourth change here. So now my create also can be implemented like this. So I will say just try to create both ways, implement this. So try create in both ways and try create using ampersand start call also. So this call to be implemented. This will tell you that any pointer can be passed as a call by reference also, and via that it will work without difficulty. From main, whatever you are calling, the same call now will be written like this. In this case, initially, even if a start is a garbage, will not make much of a problem because things are simple. Even if it is a garbage, it will have no problems because the start is not being used internally at all and initial value is not being referred at all, but changed value will come back from here, whether it will come null, whether it will come whatever. So initially you can keep start as a null preferably so that other operations don't get disturbed. But even if a start was garbage and create is called with a garbage, still it will not create any issue for us. Do this. But this concept is going to be now useful for me for using linked list storage for various operations. So linked list storage, let's say to be used for stacks. Earlier, stack using array you have done. So now I say stack using linked list. In general or in abbreviation, we say it as linked stack. What linked stack require me is that first of all, remember it's a array will not be used, so linked storage will be used. So this will also give you a flexibility that upper limit of the size need not be told. You can have as many as nodes till memory is available, as many nodes as possible, as long as memory is available. So as long as your malloc doesn't fail, you can use this. If malloc fails, of course, after that insertion won't work and push, etc. will not work or node cannot be created. So you can do that. And remember, malloc will return null. That also we have discussed in the previous class or previous classes. And we must always have a check on that. So whenever it will be null, that will mean if temp returned is equal to null, that will mean malloc was failing, and accordingly, we have to take some suitable action. But remember, mostly it will not fail. Yes, until unless we were going for malloc to be, let's say, of 10 gigabytes collectively, obviously it will fail. Otherwise, we will have a long memory, we have a good amount of RAM. So for our programs, malloc is rarely going to fail. Exception will never come. So we don't really check every time, but good programmers can do this after every malloc. Now, link the stack. So I will say effectively linked stack means singly linked list to be used, of course, nothing else. Now, instead of a start pointer, we will have the top pointer. So earlier we have been using start for the linked list. Now we will say we will use a top pointer. So top will be an index, but it will be a pointer to the linked list. So I want you to now think of doing the stack implementation using push and pop. But as you remember, in push and pop, top will change. So top will change means top should be either returned or you can send it as call by reference. So the syntax which we have just learned, we can use now the same for this situation. How to do that? Now I'm leaving to you to just think over this. But what I need is now, so if I'm trying to use push function, that will mean my push should have effectively node star star top. So top being passed as a call by reference and the value which was to be pushed that supplied. And now I should be able to do the push operation. Of course, in this malloc and whatever new data needed, etc., and linking to be ensured. Similarly, for the pop, I use int pop so that the popped value is returned via int, but the top change is adjusted via call by reference. And that nothing else will be needed. So I want this to be implemented accordingly. I suggest you to just try this and find what problem do you face. Assume some data exists, top is not nil. Assume some nodes are present in the stack. Some nodes means some data is present. And now you attempt push or pop. So special conditions we will handle later, and try to just do your push and pop over your stack via this particular case. Why I'm saying is when you try to write a code, you will find some typical problem and then we will discuss that particular problem. So I'll suggest you to pause here and think of implementing this. For example, let's assume that my stack already has got 5 and 10 and now 20 being pushed. Should be done. Similarly, if my stack has currently 5 and 10, pop should mean that 10 should be coming out. What I require, if I have already 5, if I have already 10, 20 will mean the top should also point to 20 now. Probably easy, you can think of that. And if I had 5 and 10 now, if I am popping now, so popped value will come 10, but at this present means currently top was here. After pop, the stack will get updated and my top should point to 5. Before 5 also, there could be something. We are not bothered at present. So whatever it could have, it should continue, but the top should get updated to 5. And if I'm pushing, 20 should be the topmost node and rest everything linked in the proper manner. So give a pause here, try to do that. And if you are not able to do, or if you face any problem, then my next discussion will solve that problem. I'm just giving you a few seconds of pause, and then you can resume the video once you are ready, and then we will discuss that. So I'll just give you a pause. So I hope now you are back and ready to discuss. So the problem you must have faced till now, let me explain what you saw. Let's assume we have here 5, we have 10 linked in some way, so that linking etc. exists before or after. Let's say push 20. So you could simply say, okay, push will mean I will take temp equal to malloc. So that will mean I have here 5, 10, etc. You took 20 and 20 is your temp. In my normal linked list, we have got this step done as step 1. Step 2, the corresponding data saved. If the list is already existing, the step 3 was whatever was my previous pointer, So that was, in this case, my previous or topmost or last pointer was the top. So I probably think that I should do top arrow link equal to temp. So that means now earlier top was this 10. So this was your top. So you said a top arrow link equal to this 20. And this node connection becomes okay. And then you update top. So you say top equal to 10. Let current or last node point here. Perfectly fine. We wanted this top to point to the last node. But how the pop will happen? Now pop will mean, let's say if this is the list 5, 10, 20. Perfect. This is the list available. 20 to be returned. Yes, or to be displayed. Printf return. Fine, no problem. We will be able to do that. But now top must point to previous element. Previous element in this case, for example, is 10. I want to go back. How? Not possible. Remember, it's a singly linked list. We are not permitted to use doubly linked list for such purposes only. Of course, but so I say if I have only single list, still it should be possible. Then you might think that, okay, let's store a previous pointer, although not allowed, because in stack only top pointer is allowed and nothing else. Even if you store, maybe once pop will work. What about before that? How many times you will have previous pointers? So obviously that is not going to work. So now comes the problem that it's not a standard way of working on this if I want to use it as a linked list. Then the question comes, why do you need the link to be like this? Although I am linking my linked list like this, but I will never use this particular operation in this order. This sequential access never needed. Even if I want to display stack, it is always leaf order. Whenever I want to pop, I want to go to the previous. So I never want to go to the next link. I want to go to the previous link. That effectively means when I added 20 addition to the previous top should be done in a way that you link it like this. And then you bring your top here. So link direction, if you reverse, to be reverse, will solve the whole problem. So effectively that will mean your push operation was able to add this. And if you wanted to pop, of course, 20 will come back. But simply saying top equal to top arrow link will solve the same problem for me. This will be without a problem and top will come back to the previous node. So this you can implement without difficulty, and that effectively means my stack probably whenever I created first time, the linking was, let's say, like this: 5, 10, 20. And now it is top. So every time the maintenance is like this. That obviously means for the lowest node, the previous pointer or the link pointer will be null. This should be done. But remember, in case of a push function or pop function, wherever you are writing your function, at that time of writing, you have to make sure that you use a star top because you have a call by reference to be passed. Similarly, for the pop also, use a star top, not simply only top. Having said that, I will say now again, you should be able to implement this without difficulty at all. But those who want some more help, for them, I will give a demonstration code, partial code I will share so that you can complete that code and try further. But those who want to do of their own, I think they can try and pause the video and complete the code without difficulty. So those who want to see partial code for their reference, I'm showing some code here. stdlib.h included, same node. I'll say, yes, if you need some function prototype, etc. So my main is going to have star top. Initially, top should be assigned a null, etc. So that in initially cases, failure of a pop or push whenever attempted, first time top is obviously null, that initialization will be needed, and then push and pop called. But whatever cases you have to write, accordingly push and pop with ampersand top, etc. can be sent the way we have already discussed. How will be the function? So my top being sent as a call by reference, it's void obviously. I will have some new node created. Linking you have to do carefully. And if malloc fails, of course, you can give this message. And maybe even if you don't write this, then if I assume that malloc is always successful, so just what kind of a linking you have to do, I'll leave it to you. Similarly, for the this, if stack is empty, that you should be able to write. Otherwise, you should be able to simply do. So if you say printf this and stack is empty, no empty to val, and in that case, something special to be done. And if the pop was possible, accordingly, you should be able to do that and also return the del val. So maybe you can say, for the time being, I will take del val equal to -1 and -1 being returned in general case. And if I have returned del val being returned, that will mean if the success, if the pop was failure or empty stack, then del val -1 will be returned. Otherwise, here del val will get updated, and you will be able to do that coding and put here some kind of a if, which will tell you that if I have some condition here, then you will be adding all data into this if condition. Else you will have the corresponding condition completed and doing all this work for you. So based on that, all this process will continue and you can complete your code. So I'll stop here. And then similarly, traversal. Traversal should mean the LIFO order data. So temp to be initialized. Here, call by reference not needed. So you can have your if condition added and then accordingly print the data. And if there is a stack is empty, you can give the message. But LIFO order display should be possible. I think I'll leave here and ask you to complete the code. It's quite easy. I have already described effectively. What you have understood is, in case of a push, earlier what I needed was only top, but now I have a star top. So if I'm talking of a push being called, I have already used a star top. That will mean whenever your linking was done, for example, you have taken a temp equal to malloc and malloc, etc. done. After that, data, etc. stored. But now you want to say the link to be going in the reverse direction. Not a top arrow link to be changed, but you will say temp arrow link something equal to star top. Something like this, and then rest of the code you should be able to complete for push as well as pop. And display also. Display must be in your LIF order. Always LIF order. So do this, and that should be quite easy work. Going further, again, another application. One very useful application of this can be polynomial addition using linked list. That means earlier I have used arrays for the polynomial, but now I will say I will use a singly linked list. Whenever I say using linked list, by default it means a singly linked list. Of course, doubly also you can practice, but for the time being, I'm working with a singly linked list. So that means what? Now, polynomial addition using singly linked list. Meaning that if I assume that for the time being, I am using exponent-based representation, that effectively means that I am storing for every term exponent and coefficient as a pair. This pair is being stored not degree-based. I'm not saying not currently degree-based. For the time being, we are discussing the implementation using the exponent-based representation. This also can be done, If you want, so similarly, this also can be done using linked list, and that also you can practice, of course. If I say polynomial addition using linked list, means, for example, if I have some polynomial, let's say 2x raised to 80 plus 3x raised to 70 plus 4x raised to 50 is one polynomial. Let's say other polynomial is 3x raised to 80 plus 4x raised to 75 plus 5x raised to 72 plus, let's say, minus 3x raised to 70 plus 6x raised to 50 minus 3x raised to, or let's say plus 7 minus 7x raised to 40 minus 8x raised to 30 and so on. So this is my polynomial 1. This is my polynomial 2. Polynomial 1 storage will mean each of them will be one node and linked list of nodes. So my node structure will effectively mean, in terms of a data, I will store your exponent as well as a coefficient, and I will store a link. So this is my node structure. And a node structure like this will mean that my data will be now storing both of these fields collectively. So what it will mean, my polynomial 1 should become 80 and 2 as a first term, 70 and 3 as a second term, 50 and 4 as third term, and then list ends. Similarly, so this becomes my polynomial 1. Similarly, for polynomial 2, what it will be? It will be, let's say, 80 and 3, then 75 and 4, then 72 and 5, then 70 and minus 3, and so on. So this is going to be my polynomial 2 ended with null. I want addition to be done. And addition should mean that I should generate a new polynomial named as a poly 3, which should obviously become as, say, 5x raised to 80. So 80 with the 5 as the first element. Then after that, out of this 4x75 will come. So 75 with 4 as the next element. 72 with 5 as next element. Minus 3x raised to 70 plus 3x raised to 70 will cancel each other. So this term will not come. After that, 50 term is there. So 6 plus 4, 10. So 50 with 10 as the next value. And after this, all these terms to be as it is here. So the exponent decreasing order based ordering is guaranteed. And that is the assumption of the polynomial. And I want this polynomial 3 to be generated. Implement this. So what I need now, my programming. Programming is nothing different than what we have done earlier. First thing, I have to create poly 1 and poly 2. Reading. So for this, I will say, we already have the create function. Let's reuse that. I will say, if you give exponent as -1, will mean stop reading. Otherwise, your terms are being read one after the other, and assuming they are always given valid according to decreasing order of exponent, so things will be perfect. And for the time being, I will say use something like create to do for ampersand poly 1, means call by reference to be done. So in main, create this. Similarly, the same function you will be able to read for the second polynomial. So implement create also like this. And once you have done this, I will say, let's try the add poly to be a different way implementation, where I want a poly 3 to be written as poly 3 equal to add poly 1 and poly 2 being supplied to this. So in this case, return type will be returned. So this is a different scenario. Here, no return type, all these void type. And after that, of course, you can display or traverse all that result. So this is what I want in my main. So accordingly, create function, more or less same, just exponent as -1 will mean stop. So initially -1 and -1 exponent never exist. So my same logic of create will work. Just we have to do that wherever earlier we were reading val. Now I will say I will read exponent as well as a coefficient, both to be read if the value was not -1. So first time read exponent. If exponent is -1, stop. Otherwise, coefficient also to be read and keep on repeating till you reach to the null value or exponent becoming -1. Then add poly. So that will mean my node star will be the add poly return type. Add poly will be supplied here with proper syntax for poly 1 and poly 2, etc. And now I have to do the coding. How to do coding? My coding is again simple. I can say, let's use it as a temp1 for the first pointer, temp2 for the second pointer, for the second polynomial, and both will be compared with each other. So for the time being, I can say initially poly3 equal to null, and obviously temp3 also to be initially equal to null or poly3, whatever you write. And temp1 to be poly1, temp2 equal to poly2, and so on. Whatever way. Effectively meaning, in case of a array-based storage, we used here I to be the first index. Here we used j. And for third polynomial or addition, we used k. And into the array-based storage, we have done that using ijk. Now, instead of I, it is temp1, and every time temp1 should shift. So I need some while loop to carry forward. As long as both polynomials exist, at least they are to be compared and to be checked and added, etc. You will continue. After that, one of the polynomial or both could become empty. One of them could be not empty. Then remaining terms to be copied as it is. For example, in this case, first time I will have the comparison. Their exponents to be compared based on temp. So obviously, I'm going to write if a temp1 arrow exponent to be equal to temp2's exponent. If the exponent is equal, what I have to do? Effectively addition to be done, and I have to generate a new temporary new malloc, 80 to come here, added value to come here, and this should become your temp3 also. This should become to poly3 also, and that process I have to do here. It could be that if it is done, then your temp1 also needs to be updated. Temp2 also needs to be updated. And of course, temp3 currently, if it was first node, otherwise temp3 will be always the last node over which linking to be done. So temp3 based linking if temp3 was already existing, and a temp3 based linking and updation. This is what I have to think of doing. Similarly, if this was not true, it could be that this exponent was greater than the temp2's exponent. If a temp1 exponent is greater, effectively means that I have to copy the term of temp1 or poly1 into temp3 list, and every time temp3 should be updated. So first time, for example, these two added, and then temp1 shifts. Temp2 also shifts. Temp2 also here. Now both will be compared. This is greater. So that means another node to be created. 75 as it is, 4 as it is, with the previous temp3 link to be done. Of course, temp3 also should come here now. Temp2 should be shifted because this has been exhausted. Now temp2 here. Again, temp2 versus temp1 comparison. Still it is higher. So this will mean this new node created, data copied, and this linking done, and temp3 shifted. And temp2 also to be shifted because temp2's data has been copied as it is. Now again, temp2 versus temp1, exponent same, their coefficients to be added, but because they are cancelling each other, data not to be stored, temp3 remaining here, but temp2 will also shift to next, temp1 also will shift to next. After this, let's say we have here 50 and 6, so temp2 comes here, temp1 also shifted. Now again 50 and 56 plus 4, 10. So that will mean a new node created, temp3 shifted. And after this, you can see one of the, just let me pause this. So after this, you can easily see that list1 or temp1 will be empty. Temp1 empty means whatever remaining nodes were after this, all of them to be copied. So this else, similarly, there could be another else. And after that, what you have to do is simply nothing more but just to copy remaining terms. So remaining terms could be existing. Then what you will do, copy the remaining terms of temp1 or temp2. And if any, similarly, I will say copy remaining terms of temp2, if any. I don't know whose terms will remain, but out of these two, only one of them will get used, not both. Both also might have completed, so maximum one of these will have the remaining terms, they can be used. Finally, don't forget to make the null pointer to end the polynomial 3. So that also you have to ensure. Not only that, poly 3 to be initialized to first term, that we have not done. So whenever first term gets created, that time I must be able to initialize poly 3. Initially poly 3 is null, temp3 is also null, and as soon as first term gets created, it might get created via equal exponent, it might get created via one of the exponent being higher, it might get created only when the remaining terms are copied because one of the list could be totally empty. So you have to put those corresponding checks whenever first time node gets created, whenever first node or first output node gets created. So how will you verify? By that time, poly 3 will be null, and after that, poly 3 should not remain null, and based on that, you should work. And finally, you should say return poly 3. So this you must try. I will say that can be your homework 3. So homework 1 has been DLL for insertion, deletion, add position. Homework 2 has been for your linked stack. And homework 3 now becomes for your linked polynomial addition. And that we are doing using exponent-based representation. So this becomes your addition of two polynomials. but the polynomials are linked. If you try these, you will have an excellent confidence, and all this will tell you a lot of learning. For those who are finding it difficult how to start for this implementation, I'm showing you some partial code which will help you. So I want you to implement polynomial addition, exponent based, create to be implemented, double star to be passed. Rest code is more or less same. Only what you need is a star start equal to null. And everywhere, wherever you have used a start, you will write a star start. So if you are reading exponent, if it is -1, you will stop. Otherwise, you will keep on adding. If you want to check malloc, I have just given one instance. Later, I have not assumed. Later, I have assumed malloc never fails. But otherwise, of course, you can put that. Then you can read coefficient and keep on doing that. The same do while loop, and then keeping on reading, keeping on linking, keeping on doing all that. Finally, it's all same code. Just I have, instead of one scanf, I have two scanf. Traverse. I would like you to traverse, write your traverse and display things like this. Say, take care of exponent, this power cap symbol to be written, coefficient exponent to be written, plus minus base also something. If you want, you can. This also you have practiced earlier. If find difficult, you can write simple traversal also. Just display coefficient exponent of every term generated. That will also work because that's not a big issue. Addition. Yeah, so there was some connection problem. So I'm resuming from where the video could have stopped. So we were talking of add polynomial to be implemented. I want this to return the polynomial, and correspondingly, I'll say I have already discussed the logic, which we have already talked, that add polynomial will be called, which is exponent based. Both polynomials will be passed as a call by value parameter, and result will be passed as a return type. So poly3 being all variables declared. Initially, poly3 is assumed to be null, and we have to update poly3 whenever it is possible. It will be possible only when the first node gets created. So in all of the code, we have to think wherever it is possible. At that time, if checking if poly3 equal to null, then poly3 should be updated. And after that, it will not get disturbed at all. Similarly, temp1, temp2 to be taken, temp3 to be taken. While both of the lists are non-empty, you have to continue as long as both can be compared, both terms exist, exponent-based comparison done. If their addition is resulting into non-zero value, and then new term will get created. For new term creation will mean a temp equal to malloc, new term to be added to the temp3 list. Initially, temp3 list could be empty, so you have to take care of those, and in that case, poly3 to be updated. If it is already existing, this add this and update temp3 also. So temp1, temp2, 3 will be going to the latest pointer, or whichever is the temp3 to the last entered or last added node, and temp1 and temp2 to go to the term being tested for exponent comparison or to be added if at all possible. And if the coefficient is not equal, that means temp1 and temp2 to be updated, but temp3 is unchanged. Similarly, if first exponent is greater, that means term from temp1 or first polynomial current term to be copied into temp3's list, and accordingly temp1 and temp3 to be updated. Similarly, other case means temp2's term being copied. That will mean temp2 to be updated, temp3 to be updated, and whenever poly3 gets initialized, that also to be taken care. Then one of the list could be empty, other could not be empty. So we will check if first list has some more remaining terms, copy one by one all those terms and add it to the temp3 list. Even at this stage, temp3 could have been null. Then similarly to be done for the second list if there are some remaining nodes. Once you come out of all loops, you have to take care that finally the list gets ended with a null pointer. Towards the end, the poly3 list gets terminated with null, so that traversal will not have a problem. And then you will say poly3 to be returned. Then you will read polynomial 1 using create with call by reference. Poly2 to be read using create call by reference. Poly3 to be as a node star returned, so no call by reference. and directly. Then you can print it in any form. If you print the traversal in a good way using this plus, minus, and all those symbols. So I'm just maintaining that I will write within square bracket first polynomial. Then first polynomial printed within square bracket. Second polynomial printed within another square bracket. And then final polynomial being printed. So you can write accordingly traversal logic. Otherwise, of course, you can simply print the exponent and coefficient for every term generated. That will also do the work because that's not that important. So do this, complete this code. And if you find any difficulty, my next video will show and discuss all of this code. But by now, you should be habitual and doing more of coding of your own. You should be less dependent on me showing the code and you practicing or you looking at and then trying to solve that. Then I'm also sharing with you certain practice problems just for your reference. I'm showing this as a part of video also, although I'll be sharing the soft copy with you. So for queues based and multiple stacks or row major based, these are the problems which you must practice. So I'm sure some of you could have done many of these problems, but those who have not done or those who want to try, for them the list is being listed here. All these problems are easy and average level. Difficult problems are marked already with the star or double star. So those you may leave if you find difficult. Pointer based, these 4 or 5 problems, very simple and useful practice problems. You should do these. Linked list based, initial problems are mostly what we have discussed as a homework or a practice problem. So all these are more or less the same way. Do all these. Most of these we have discussed at one or other point, except for reversal of the linked list. So reversal we will talk later. Rest everything you can practice now without much difficulty. DLL also, doubly linked list we have discussed. Insertion, deletion, add position we have discussed. All the various operations before, after we have discussed. So you can implement all these. Except reversal, everything is done. This is a kind of a merging logic. This merge problem I have given for equal length merge problem I have given as a practice problem. This is another merging problem. And this is a merging for unequal lists also. Similarly, comparing two lists for recursive and non-recursive both possible. Recursive will be slightly difficult. You may think double star also we have used that also. Now you can use linked list to be split into 2 lists based on some criteria. That is also mentioned here. Similarly, linked stack we have done. Doubly linked lists to be merged, concatenate 2 circular lists. So circular list we have not discussed till now. We will talk in the next class. So all other problems we have probably discussed or you can do based on whatever we have discussed. Exponent based representation, polynomial addition we talked today. Degree based also you can think of doing like that. These are relatively difficult problems. So except reversal and circular list, all other concepts have been discussed. And now you can practice all these problems and learn a lot. I'm sure this will give you a lot of confidence and you will also get a passion of programming. You will start enjoying this. It will not look to be a boring work for you. Bye-bye. All the best.